Here's our practice screencast, so you can see how it's done. I have opened up Screencast-O-Matic, and I have my PowerPoint already up, ready to go. And so this is what's going to happen. And when you talk about results, you should have a graph that shows what happened, and you would talk about what it means. For instance, in the control, there is no bar, meaning that there was zero zone of inhibition, meaning that the bacteria grew right over the piece of paper. None of the bacteria were killed. Compare that to neomycin, which had a zone of about 17 millimeters, meaning that there was a clear zone between the disc and where the bacteria started to grow. 91% alcohol only had a zone of about 3 millimeters, if you follow over, and that's not near as good as the neomycin, which is a type of antibiotic. So 91% alcohol, still better than the control, but not as good as neomycin. The strengths, weaknesses, and improvements. The strengths were that this experiment was done in a timely manner. It had an incubator which kept temperature constant for all the Petri dishes. Weaknesses would be that there weren't sterile pieces of paper. We can actually purchase sterile pieces of paper, but they're kind of expensive. So that would be a weakness. If you were to do this in a real microbiology lab, you would have access to sterile paper. Another weakness was I only did one Petri dish. I did not do multiple trials, so that would be a weakness for mine. So a way to improve that would be to have sterile paper and to do multiple trials. Application, how to use this information. Well, if I was going to disinfect a cut or a scrape, I would probably use neomycin from the nurse rather than put 91% alcohol on it, because you definitely will kill more bacteria using the neomycin. All right, so that is how we end it. You click here